Welcome everybody to my channel. Today we will talk about the Cone Twist Constraint that we will add it to this fridge door, so it will rotate according to the force that's being applied to it. So hopefully you will enjoy it, and thank you for your support. Let's go there. And also you are welcome to support me on my Patreon page, Fadi VFX, here where I put all of my scene file, tutorial, tools, HDA, all of the models, everything, and this being updated weekly, sometime every other day, with all of my ideas, researches, and R&Ds, and everything that I am doing with Houdini. I'll just submit it here, but with your support I'll be able to continue to add more content and hopefully upgrade my computer to add more complex and heavy scenes. So your participation is very much appreciated, so thank you very much. So this is Fadi VFX on my Patreon. So as you can see, we have this fridge model, and it consists of the front door with the handle, and we have the box of the fridge with some shelves, and we have here the frame. Also we can see a pull here at the side where the door will rotate. So after we imported the model, we split it, so we have the bottles away, and now this is the body of the fridge using the split node. So we have the bowl, we have the fridge box, and we have the door, and we want the door to have a cone twist constraint to the bowl here, to these two, and we will do it on this part at the center of the ball axis. So first thing first, we will make the ball a little bit shorter, smaller, something like this, and it's not touching the frame of the door. So we make it very, very tiny and small, and then we add assembly node for it, and we'll call it ball, and it is backed primitive, so it is 1 point now. After that, I want to copy and transfer this ball part or piece down here, so it will be a part of this door. So transfer, and I make it a little bit wider and move it down, as you can see here. So this part will be connected as a constraint to the ball here as a cone twist constraint, and the door, all of the door, will be connected as a glue constraint to this part. Okay, after that we'll add another assembly node, and let's call it top ball. Now we have this part and we have this part, and each of them, they have a name attribute, unique name attribute, so we add a merge between both of them. Now we have 2 points, like if we go here centroid, so we have 2 points, 0 and 1, and each one has its own unique name. So we add an add sub. In the add sub, we go to polygon and we add by group, so we have a line. So here we have the 2 points and we have the line. Now what's left is to add attribute triangle, and this attribute triangle, it will run on the primitive, so it should be on primitive, and we'll write string at constraint underscore name is equal just name it cone, and string at constraint type will be equal to all, so position and rotation. So if you view it, the spreadsheet again, so we have it here, cone twist and all, so we have a name now. So we'll create RBD solver, gravity, ground, a merge node between the ground, the gravity to the solver, and the output. And here we'll create RBD backed object, and the RBD backed object, the first one will be the door. So we'll drag the door out, so we have the door and it will just fall down. We will remove this. Next we create another RBD backed, this one, and this will be the static object, so we'll make it static and we connect. We need a merge, no, this is the wrong one. It should be the rigid body solver. Yeah, it look like this. You see now? Yes. Next we need this small piece here to connect with this one, so let's find it. It should be in the assembly here, this one, this part. So we create a null and we call it hook out. Let's copy it. Here we create another rigid body, we add it and we can drag. So now we have that part and it fall down. So for now we have the door moving, we have that speed moving, and we have the static part. So now we need to go and create the constraints. So we need constraint network. We'll add it here. We need Cone Twist Constraint, and we need glue constraint also. So we have these two parts with Alt, and we connect. Now the idea is the following. I have here, as we said before, I have two constraints. This is the cone and this is the glue. They are merged together, so we have one null output. This is where the constraint network will look for the constraint. So we need to connect this one to the constraint network in the sub path. So I'll just drag it here. Okay, so now the constraint network can find the constraint name and type. Now we define this constraint. So the first one, constraint twist, we go down, we should have a name. What's the name that we call it? It's this one, Cone. I'll just copy it and I go to the constraint here and add it. So as you can see, it pop up here. The second one is called a glue. I'll just remove it. If we look, see, we have the constraint, and the other one, the constraint. Now if I leave it as is and let it to play, so it go crazy. So let's set up the constraint network. Here I need to define the axis, the goal up axis, the twist axis, and this parameter. So here I don't want any movement. If we view it, see, this is the way it is moving. So I don't want any movement, but I'll just keep it here for reference. And this is the twist, how much it will twist. Full circle, 45, and so on. But the axis is up. We wanted in the x-axis. So here I'll change it 0, 1, 0 and 0, 0, 1. Sorry, 1. Okay. And here we'll make it 0, 1, 0. And here 0 should be 0, 1. So as you can see, now we have something. Let's play with it, and it went crazy. If we go to the glue constraint, let's make it -1 so it don't move. And here the wrist length on the cone twist is 1, so we'll make it 0. Now it's hanging. And this movement, you see the door moving, is because of this rotation. So if we make it 0, it won't move again. If I make it, if I make it very high in one axis, now it's rotating, or like this. Let's add some force so it will move it. Let's try maybe adding here some velocity on the positive Z. Let's add 5. As you can see, again, if I make the twist rotation 0, it won't move. If I make it 180, now it's moving. something like this. Now if I make the 180, let's say 40, let's make it 90, so let's view it from the outside, and we'll merge it. Where is that cabinet? Fridge. Maybe I'll make it smaller than this one. Let's make it 45. Let's view again. Here we want the rigid bodies only. Let's unpack. Something like this. Let me run a flip book, quick one, and maybe some lighting. Here's some lighting, area light. This is my scene that I'm working on. Anyway, let's do a flip book. So as you can see, it open, slam, and go back. Let's close it now. For the scene I'm working on, I have let's view the imported cache. Maybe I'll go to the DOPnetwork. Here I have a couple of things. Let me remove the bottles and put this one. See here the constraint with some movement. And there is another constraint that I am using, is the spring constraint, this pink one. So let me hide the rest. And let me hide this one, maybe this one. As you can see, it will drag it back. And this one completely depends on the density of the object. But in the Cone Twist, if I make it 90, drag it back. In the constraint spring, if I make it 10,000, bring it back very quick. If I make some movement here, funny. So maybe 1 and 1, and here we'll make it 180. See, if I disable this constraint, cool. bring it back. So hopefully you enjoyed the tutorial, and it will be available on my Patreon page, both of the file later on. So wish you to support me over there, and have a nice day.